The hurricane, the largest storm on Earth. An irresistible force, a wind of overwhelming destructive power. It rips buildings apart. Its heavy rain floods the land. Hurricanes, the unleashed fury of our raging planet. Each day, a hurricane can unleash as much energy as 8,000 1-megaton hydrogen bombs. A hurricane can be 1,000 miles across. It generates torrential rain. The record is 40 inches in 24 hours. Hurricanes are truly one of the most devastating forces on our planet. North Carolina, the 6th of September 1996, the morning after Hurricane Fran. In one night, the storm did $3.2 billion of damage. 27 people died. Homes were torn apart by winds gusting up to 130 miles per hour. A 10-foot surge in sea level inundated the shore. In just 4 months in 1996, 3 hurricanes struck America's southeast coast, causing property damage of $3.5 billion and killing 41 people. Hurricane Fran was the last of the 3, and by far the most violent. Our cameras followed them all. Although hurricanes were not given names until 1953, they've always ravaged the coast of America. In the days before sophisticated forecasting, the damage and loss of life from hurricanes was appalling. The hurricane that hit Galveston in Texas on the afternoon of Saturday, the 8th of September, 1900, was the worst weather disaster that has ever struck America. Thomas Edison used one of his earliest film cameras to record the aftermath. Estimates for the death toll ranged up to 12,000, most drowned in the tidal surge. If the great storm that struck Rhode Island in 1938 would strike again today, the death toll would be much larger. The population has increased so much that countless modern shoreline homes would be inundated. Downtown Providence was under 14 feet of water. 600 people died. Hurricane Camille struck Mississippi and Louisiana with winds of 200 miles per hour, perhaps even higher. It was probably the fastest hurricane wind ever recorded. 30 inches of rain fell in just 6 hours. The tidal surge was 27 feet. 26 people held a hurricane party in a supposedly storm-proof concrete building. All but one of them was killed. The only survivor floated out of a third-story window on a mattress before the building collapsed. Then, in the 1970s, satellites began to make accurate forecasts possible, but still nothing could stop the hurricanes themselves. Hurricane Gilbert in 1988 was huge. It covered the entire western half of the Caribbean and much of the Gulf of Mexico. The lowest pressure ever recorded in a hurricane was in Gilbert's Eye. When it struck, it was the strongest hurricane to make landfall in 19 years. Hurricane Andrew in August 1992 was more costly than any previous hurricane. It struck a densely populated area on the Florida coast, just south of Coral Gables. Andrew laid waste to everything in its path, and then barreled across the Gulf to strike near New Orleans 2 days later. Year after year, hurricanes strike with relentless power, bringing tragedy and devastation to our planet. It's a powerful incentive for science to understand them and to predict better their paths to help people escape their fury. The Atlantic hurricane season starts when summer arrives, and the water off the coast of West Africa begins to warm up. Thunderstorms develop over the land and then drift out to sea. Each year, 100 small storms reach this stage. If the water temperature is 80 degrees Fahrenheit or more, those storms may intensify and organize to form tropical depressions. Within 2 weeks, this small low-pressure area can become the most powerful weather system in the world. The warm ocean heats the humid air, causing it to rise, and then the water in the air condenses to form clouds. The air beneath is driven up even faster, sucking in more air from below. The new air spirals in, it also rises, sucks in more air, and the system gets stronger and stronger. This is the engine that drives the hurricane. As trade winds push the entire system west across the Atlantic, the spiral tightens, and the storm becomes even more powerful. A column of clear air develops. This is the eye of the storm. Here, updrafts surrounding the eye are balanced by air going back down inside the eye. Somewhere out in the Atlantic, when the winds exceed 74 miles per hour, the storm becomes a hurricane. In Miami, meteorologists at the National Hurricane Center monitor these storms 24 hours a day. They aim to predict which depressions will develop into full-fledged hurricanes, and which of those will threaten America. These are the people who must try to decide which storm will prove to be dangerous. As a result of the decisions they make, thousands of people will be evacuated. But if they make a wrong call, millions of dollars will be wasted, or thousands of lives put at risk. To attempt a forecast, they need precise information on what each storm is doing while it's still thousands of miles away in the middle of the ocean. They get reports from ships, commercial flights, special hurricane hunter planes, and from coastal radar. But their best source are satellites thousands of miles out in space.
5, 4, 3, 2, and ignition. All engines are up and burning. We have liftoff of the Atlas Centaur 77 and the GOES-J weather satellite.
The newest weapon means for monitoring the storms are the new Geostationary Operational Environmental, or GOES satellites. These satellites sit in stationary orbit 22,500 miles above the equator. Their cameras can scan the visible half of the globe, generating images in both normal and infrared light every 30 minutes. They use the images to look for distinctive swirls of clouds spiraling away from the equator. Only from space can one appreciate the true scale of the hurricane. A hurricane can be up to 1,000 miles across, so huge that its top presses against the ceiling of the lower atmosphere, some 60,000 feet high. Its awesome beauty and apparent calm belie an inescapable truth. Hurricanes are killers on a titanic scale. Every year in America, they will kill scores of people and cause billions of dollars worth of damage. But the greatest killer is not wind, it's water. The low pressure of even a Category 2 hurricane is powerful enough to suck up the ocean into a 3-foot dome. As the winds drive the surge towards the land, the dome can build to 8 feet or more. And in places where the shoreline is shallow, the storm surge can reach nearly 30 feet high. Billions of tons of water wash over the land with incredible destructive power. This is Hurricane Opal, as she came ashore at Pensacola, Florida on October the 4th, 1995. Opal caused huge floods. Opal surprised the forecasters when she suddenly strengthened in the last few hours before coming ashore. At one point, it was so strong it had gusts up to 150 miles per hour. But even worse, the surge and waves combined to produce a 15-foot rise in sea level. Of all the people who die in hurricanes each year, 90% die by drowning. It's difficult and dangerous to study the effects of a real hurricane. But a laboratory wind tunnel can safely recreate the conditions that exist in the heart of the storm. Throw the switch, and you create an artificial hurricane. Hurricanes are graded in 5 categories. Category 1 goes up to 95 miles per hour. The damage is mostly to trees and foliage. A little more than that, and the asphalt roof shingles begin to lift. Take the wind speed over 100 miles per hour, and some of the shingles begin to tear. Up to this point, the heavier ceramic shingles suffer no damage. But as the wind speed edges up towards 110 miles per hour, even these tear away. The wind in the tunnel is now rushing at over 110 miles per hour, the upper limit of a Category 2 hurricane. A mere human can barely face into the wind, like this stuntman who acted as our test subject. In extreme slow motion, the camera captures the destructive power of the hurricane. The air fills with flying debris. Even a trash can becomes a lethal missile. At 111 miles per hour, it becomes a Category 3 storm. The ceramic shingles have long since been ripped away. Amazingly, the flexible asphalt tiles are still in place. They are now taking the full force of a Category 4 hurricane, over 130 miles per hour. The wind hits with crushing force. It punches the air from your lungs. Our test subject could only take it for 15 seconds. Without his safety harness, he would have been thrown through the air. Around the world, hurricanes kill thousands every year. They are killer winds. around the Atlantic and parts of the Pacific are they actually called hurricanes. In different countries, they go under different names. In the Western Pacific, hurricanes are known as typhoons. Typhoons are often more powerful than Atlantic hurricanes because they have a greater area of warm sea to travel over to build up their power to full strength. On average, Japan is hit by 2 strong typhoons every year. That country has been devastated by some of the most powerful winds ever experienced anywhere in the world. Not only are typhoons bigger than Atlantic hurricanes, there are also twice as many of them. There are more than 20 full-strength typhoons in the Western Pacific in an average year. In Australia, the same storms are called cyclones. In the southern hemisphere, the winds in the storm rotate in the opposite direction, clockwise around the eye. Australia's worst ever cyclone struck Darwin on Christmas Day in 1974. It killed 48 people. The damage to Darwin was terrible. Most of the town was destroyed in this single storm. Cyclones also strike the coasts of India and Bangladesh.
Most of Qutb Dia disappeared under 20 feet of seawater.
This is one of the most densely populated regions on our planet. Here they kill on a massive scale.
Poisonous filth has been left behind by the floods. 60% of the island's population, about 75,000 people, were killed.
Bangladesh, because it's so low-lying, is especially at risk. In a single night in 1991, Cyclone 2B took 138,000 lives. But Bangladesh's worst cyclone drowned more than 300,000 people.
Cyclones and floods are common in Andhra Pradesh every year. But this year, tidal waves and hurricane winds with more than 135 kilometers per hour.
In India, too, cyclones are regular and devastating. Like Bangladesh, the land here is flat, and the cyclone's rains bring massive floods.
It's much more this time.
Cyclones can also destroy the lives of those who survive. The storms ruin crops and smash houses. The typhoons and cyclones of Asia may be the biggest killers, but it's the Atlantic hurricanes that get the biggest headlines. This is Hurricane Gilbert, which in 1988 swept through the Caribbean, slammed Jamaica and the Cayman Islands, charged across the Yucatan Peninsula, and struck Mexico. Cyclones, typhoons, hurricanes, the name may vary, but their destructive power is the same the world over. Early in July 1996, at the National Hurricane Center in Miami, the mood is tense. The second storm of the season has them worried. Its name? Bertha.
I just got another report. The planes right now, they're handed it to me, and they found a peak wind of 110 knots.
It looks as though Bertha will strike the Atlantic coast. The forecasters must now make critical decisions. The key questions are, precisely when and where will it strike? And most importantly, how violent will the hurricane be? As Hurricane Bertha approached America, it brushed Puerto Rico, gaining strength as it passed.
I can tell you the damage here in Puerto Rico so far seems to be minimal. We've seen a few roofs blown off. Hurricane came through here.
Puerto Rico is lucky. Bertha passed 140 miles to the north. Its strongest winds got up to 115 miles per hour, a damaging Category 3 hurricane, but fortunately out to sea.
Taking it seriously here until the cleanup effort is over.
As it traveled, Bertha began to lose its shape. It curved north as most hurricanes do, and it began to look as though South Carolina was in its path. But satellite data alone cannot give the forecasters sufficient information for the accurate predictions they need to make. The only way to get precise details is to be there.
I want to let you take it on radar until about we get through the strongest winds, and then we'll kind of talk.
This is the job of the U.S. Air Force 53rd Weather Reconnaissance Flight, the Hurricane Hunters.
Come back in from the southwest, Bob.
So we'll do northwest of the last leg.
They can fly right through the center of a hurricane to gather data. Their information helps the forecasters make their predictions more accurate and increase the safety of threatened communities.
Position you'll be going to is this red little hurricane symbol right here. Looks like it's about 150 miles directly off from Cape Canaveral, due east of Cape Canaveral. And if you've been watching on the Weather Channel or anywhere else, you've noticed the storm covers an area about like this size. The storm now is kind of paralleling the Florida coast, and that's what we expect it to continue doing right now. Takeoff is approximately 3:30 local this morning, and you'll be flying on C-130, tail number 967.
The Hurricane Hunters had already been watching Bertha closely for several days, flying 3 planes in 12-hour shifts. A crew would now stay with her constantly until the hurricane made landfall or dissipated and the danger faded away. Bertha seemed set to strike within 48 hours. To the forecasters, the media are the only way their warnings are heard. At the Hurricane Center, an entire room is set aside for the media's use.
The experts here are saying that they expected Bertha to make that...
But the Hurricane Center was still not certain exactly where Bertha would make landfall, and they were running out of time.
South of Wilmington, North Carolina.
So they issued a warning along the coast from mid-Florida to North Carolina. If they hadn't, there wouldn't have been enough time to evacuate. Every year, many people evacuate, only to find that the hurricane has struck elsewhere. But for others, the evacuation saves their lives. July the 11th, 4:30 a.m. Bertha was about 30 hours from landfall. The Hurricane Hunters headed into the storm for their first fly-through. Bertha was now 200 miles off the coast of Georgia, and winds at her center had dropped to 80 miles per hour. The storm was traveling towards land at 9 miles per hour. The Hurricane Hunters' job now was to make sure the storm pulled no last-minute surprises. In South Carolina, the evacuation was well underway, with 24 hours to go. The forecasters were almost certain that Bertha's heaviest strike would be along the stretch of coast centered on Myrtle Beach. The evacuation zone spread 120 miles along the coast. It costs $200,000 to repair and evacuate each mile. The cost of an inaccurate prediction can be huge.
Mandatory evacuations have been issued for all of our area beaches. These are pictures from Riceville Beach, where residents have been evacuating all day.
The Hurricane Hunters prepare for another flight through the heart of the storm. Their planes are 30 years old. This plane has probably flown through hurricanes more than 300 times. Bertha's final destination was no longer in question. She was going to strike land. But the information the Hurricane Hunters gather could help the forecasters predict her strength and arrival time with greater accuracy. They entered the storm at 10,000 feet and flew as level as they could, straight through it.
Came in from this way, hit the storm, went out that way, out to 150 miles, came in, marked it right there, over, third was right there.
On each flight, they fly through the hurricane at least 3 times in different directions. 10,000 feet below, the waves were becoming enormous. At this point, Bertha seemed to be losing her structure. Her eye had lost its shape. As they banked around for their third pass, the swirl at the heart of the storm was visible 50 miles to the left. The data relayed back from the hurricane hunters showed that Bertha's winds had slowed a little, but not enough yet to relax. Hurricane forecasting took a big step forward with the introduction of the new Gulfstream G4 research plane, which can fly higher and faster than its predecessors. Forecasting weather accurately mostly depends on the quantity of information you have. The new plane will probably double the amount of data the forecasters can get. They hope to improve the accuracy of their hurricane forecasts by as much as 20%. Late afternoon, Myrtle Beach, South Carolina. The center of the storm was predicted to hit somewhere around here at noon the next day. In just 18 hours, this coast would have to endure winds of up to 100 miles per hour. A few brave, perhaps foolish people stayed to ride out the storm. Sometime during the night, the first bands of rain would arrive. In addition to the wind and the storm surge, there would be 8 to 12 inches of rain over the next 24 hours. For the most part, Myrtle Beach was now deserted.
Reports from an Air Force plane and Doppler radar from Wilmington indicate a maximum sustained wind of 105 miles per hour, some fluctuation in intensity. Expected before landfall, winds have already begun to increase along the coast in the warning area.
As darkness fell, thousands of evacuees settled in for the night in makeshift dormitories at inland schools, following the course of the hurricane by listening to the media.
What's the latest down in Myrtle Beach? What are the winds there? I tell you, we're not getting a whole lot of wind yet compared to what you're talking about if you're looking for hurricane force winds. I've heard gusts up to 60 miles an hour on the Springmate Pier, and that was an hour or two ago from our last check-in with our weather guys.
It was a night of uncertainty. By the next evening, they might not have a home to return to.
Yeah, we are anticipating it to be a real long day.
The next day, during the night, she had turned slightly right. Instead of Myrtle Beach, Bertha was now aiming at Wilmington, North Carolina, 75 miles further north. And suddenly, her winds had increased to over 100 miles per hour. Wilmington Emergency Control Room.
Another 300 cops on standby.
This was the control center that would manage any disaster Bertha would bring. Just 2 hours before landfall, the team were making sure that everyone was as well prepared as possible.
Site coordinator for Blair School to open up after the shelter if need be.
Okay.
We've got an alarm that we can't turn on to Trask. It's a fire alarm. We need to get somebody to deactivate the fire alarm.
Can we get them on the phone just to do it reset?
They were deciding where to house more evacuees.
The other question is whether or not we need to open up, looking for staff to open up.
They must be prepared to deal with collapsed buildings, power outages, blocked roads, and any deaths that Bertha would surely cause.
CF-10's clear back the fire ground.
Yeah, once the winds had died down so we could expand.
Yeah.
The center of Hurricane Bertha, located near latitude 32.8 north, longitude 78.4 west, 105 miles south of Wilmington. Bertha moving toward the north at 13 miles per hour. This is expected to continue today.
A lot of wind right now, really intensifying. I got the mayor. Are you ready for this? Are you prepared?
Well, as prepared as you could be. I mean, you can't move your house.
Yeah. Figured if the weather got bad enough, we just float on down the river. Looks like it's really starting to come.
Yes, it is. The outer band has just reached us at this time, and we're expecting upward 60, 70-mile-an-hour winds.
In Wilmington and on the coast, the winds started to pick up.
As
is moving just north of east toward the coast. We should have landfall here within the next couple of hours. Winds remain about 105 miles per hour, and its forward speed is about 13 miles per hour.
Friday, July the 12th, the leading edge of Hurricane Bertha struck land at Cape Fear. Bertha hit further north than the original forecast, a little later and a lot stronger. Fortunately, this stretch of coast had been evacuated. The time for preparation was now over. For the next 5 hours, Hurricane Bertha would do her worst.
GNI continuing our up-to-date coverage of Bertha. It is 11:40. Bertha has strengthened to 105 mile-an-hour winds. All preparations to protect life and property should have already been completed.
We're blowing here. Stand.
In the Wilmington emergency room, all they could do was wait. Anyone who got badly injured, or who happened to be in the wrong place, was helpless in the teeth of the storm. Once the winds were up to 70 miles per hour, the emergency services did not respond. All they could do was work out the priorities for when the hurricane had passed.
In a minute. Anything else? You need anything down there besides the roof for next door?
The radar shows how Bertha struck the coast a glancing blow. It took a while for the most powerful winds to come ashore. They were terrifying and deadly. As is usual, the strongest winds and the biggest floods were to the north of the eye. Surf City, 25 miles north, lost its pier.
Several buildings have lost their roofs. A lot of damage already. And the storm, unfortunately, if we can believe the forecasters, is not even really here yet.
With the storm surge of 6 feet, the sea began to overrun the land.
This is what it feels like to be right in the center of it if you go around this corner. And it's nasty, and I'm going to get the heck out of it. I've been through blizzards. I've never been through a hurricane. Say it again, I'm sorry. I've been through blizzards, but I've never been in a hurricane. Well, now you can say you have been, definitely.
Bertha pounded the North Carolina coast with winds of more than 100 miles an hour. Then, suddenly, a measure of peace returned. In the eye of the hurricane, blue sky even appeared. The winds and rain faded to gentle background. The storm was only half over, but the destruction was tremendous. In every hurricane, this pause gives a false feeling that it's all over, but it's still too early to start the real rescue work. After the eye passes over, for the second half of the storm, the winds will come from the opposite direction.
This may be our last live report because I don't think we're going to be able to get through this.
The storm surge was 6 feet, but Bertha came ashore at low tide, so the effect was less. Had she come in at high tide, the surge would have been 4 feet deeper. By the next morning, Bertha was gone, her place taken by a clear blue sky. Carolina Beach is normally only a few feet above the ocean, and the flood still had not drained away. Getting the town back to normal would take months. With Bertha gone, the repair teams moved in. In Wilmington, they had to move 31,000 tons of downed trees and branches. 113,000 homes lost power, and 12 people had died. But even with the hurricane gone, the coast was still off limits.
Okay, not right now you can't. The beach is still closed.
It would be another 2 days before these people could return home to discover if Bertha had left their homes, possessions, and lives in ruins. Now was the time for the cleanup to start, with help from wherever it could be found. In just 24 hours, Bertha decimated 50 miles of the North Carolina coast. Bertha was the first hurricane of the 1996 season to make landfall. It caused $270 million worth of damage. Hurricanes can easily turn even a single plank of wood into a destructive missile. Any high structure is exposed to the full force of the wind. Hurricanes cripple communications and electrical services. Roads are blocked, slowing the efforts of the emergency repair teams. Many roads can be completely destroyed. The storm surge and the wind-driven waves simply wash them away. The tidal surge floods the coastline. A hurricane can leave boats stranded on land, heaped in a costly pile. Back in Miami at the Hurricane Center, the forecasters are tired but pleased. Their prediction of Bertha's path had been accurate enough to evacuate the right parts of the coast. But they were still on duty. On average, there were 6 Atlantic hurricanes per year. Somewhere out there, another killer hurricane could be brewing. The next hurricane to pose a threat was Edward. Most Atlantic hurricanes come low into the Caribbean and then curve north. The challenge is to forecast the degree of turn. In 1992, Hurricane Andrew hardly curved at all and slammed into Florida. But Edward turned so far north that it looked as though it might miss land completely. But it straightened a bit and brushed Nantucket Island on the 2nd of September, killing 2 people. Edward was the most powerful hurricane of the year, but fortunately, it stayed mostly out to sea. On August 25th, it became a full Category 4 hurricane, with winds over 140 miles per hour. For the next 9 days, the winds never dropped below 115 miles per hour. In the overall scale of hurricanes, neither Bertha nor Edward were seriously damaging. With the 1996 hurricane season now half over, so far, America had been lucky. But then, right after Edward, came Fran. As Fran's path curved north, the storm grew and the winds increased. When it made landfall on September the 5th, its winds gusted to 130 miles per hour. And as luck would have it, Fran smashed into the same stretch of North Carolina's coast that Bertha struck just 8 weeks before. Fran was a giant. shore at 8:45 p.m. on September the 5th, the Thursday after Labor Day. This is exactly the same resort town, Carolina Beach, that Hurricane Bertha had swept through.
The flash flood warnings in effect for the whole Cape Fear region. Watches elsewhere, hurricane warnings again in the coastal areas, high wind warnings inland. Also, we do want to keep reminding you that there's a tornado watch in effect for the next several hours at least for the entire area.
Besides her strong winds, the storm surge was 8 to 12 feet. And that's what did the most damage.
Some safety tips for when the eye is in the area. That's going to be the strongest part of the storm, of course. Stay on high ground and inside a sturdy structure. If you haven't made it to an evacuation emergency shelter, you need to do that.
Fran was a fully fledged Category 3 hurricane. Fran killed 27 people. She destroyed almost 2,000 homes. The total cost of damage was $3.2 billion. Luck had run out for the people of North Carolina. Fran had destroyed any hopes of a quiet hurricane season. After she made landfall, Fran passed over Washington and dumped the wet remains of the storm all over the area. In just a few hours, 4 inches of rain fell on the capital and up to 14 inches in outlying areas. The Potomac River rose 7 feet above flood level and burst its banks. Streets only a few blocks from the White House were blocked with sandbags. Fran caused some of the most damaging floods the Washington area has ever seen. Satellites recorded the entire 1996 Atlantic hurricane season. Here, condensed to 30 seconds, is all the weather from July to October. 9 hurricanes formed, 6 of them were Category 3 or more, the largest number since 1961. But only 3 struck America. They took 41 lives. Most years are far worse. Scientists have recorded the tracks of Atlantic hurricanes for over 100 years. It's a powerful visual reminder of the difficulty of forecasting these terrifying weather systems. Most hurricanes come west across the Atlantic and curve north as they approach America. The details are so complex that to use these records to decide where the next hurricane will go appears all but impossible. Yet, science's understanding of our planet's complex processes is now making accurate prediction a reality. Hurricane forecasts get roughly 1% or 1 mile a year more accurate. Each year, fewer people get evacuated unnecessarily, and warning times get longer. But more and more people move to the coast every year, so when they do evacuate, it takes longer. The forecasts are earlier and better, but the overall situation actually gets worse. Someday, the heart of a big hurricane will pass over a major city. New Orleans, Miami, or Atlantic City. The devastation would be horrific, but it's certain that future hurricanes will bring more damage and more deaths to our raging planet.